Hello, welcome back to the Blank 75 series. So this is the third video of the series. So today we are going to solve contain duplicates. Given an integer array nums, return true if any value appears at least twice in the array and return false if every element is distinct. Okay, so you are given an array and if any element is appearing twice in the array, you have to return true. Like this example, 1, 2, 3, 1. You can see 1 is appearing twice. So we are returning true here. And in this example, every element is distinct, so we are returning false. Okay, so simple question. Now let's go to whiteboard and see how we can do this question. Okay, so this is the array we have, and now we have to calculate whether this array contains duplicates or not, right? Okay, so let's talk about the first approach, that is the brute force approach. So the brute force approach will be, we have to create two variables, I and j, okay? And we are going to check all the possibilities, all the possible combinations of this I and j. What I mean by that is, let's say, my I is pointing at the 0. Okay, my I is pointing at the 0 and my j is pointing at this 1. Now we are going to compare these two values. If both the values are equal, we are going to return true. Okay. Okay, now let's try to equate both the values. Compare both the values. That is I and j. If 1 is equal to 2, is 1 is equal to 2? No, it is not. Increment j. Again check. Is 1 is equals to 3? It is not. Increment j. 1 is equals to 2? No, it is not. Increment j. Again compare. 1 is equals to 5? No, it is not. Increment j. J is exhausted. So at this point, we are going to increment I. Now we are going to increment I. So now I is pointing here and j is pointing here. Both are equals? Like, are both equals? No, they are not. So increment j, right? Are both equal? No. Sorry, they are equal. Right. This is 2 and this is also 2. If both are equal, here we will return true. Okay. And if after like checking all the possibilities of I and j and we have not returned true, it means there are no duplicates and we will return false. So this is the brute force approach. This is our first approach. The time complexity of this approach is what? N square. Okay. Because for every I, we are calculating j. Sorry, for every I, we are iterating over the whole array, right? For every I, j is iterating over the whole array, right? So the time complexity is n square and the space complexity is constant because I am not using any extra space. Okay. Okay, now let's talk about another approach, a better approach than this. Okay, let me erase this first. Just a second. Yeah. Okay, so the next approach will be the sorting approach. Okay, the next approach will be the sorting approach. This is 5 and this is 2. Okay, second approach, this will be sorting approach. Okay, so we have to sort this array first. So let's sort the array. After sorting, the array will be 1, 2, 2, 3, and 5. This is the array, right? And in this approach, we have to create a variable I. Let's say we have created a variable I, which is pointing at 0 first. Okay, and we have to compare this variable I, sorry, this value a of I with a of I plus 1. This is I plus 1, right? So we have to compare. Let's say this array is ARR. So we have to compare ARR of I with ARR of I plus 1. Sorry, let's write it here, AR of I plus 1. Okay, we have to compare these two values, and if both the values are equal, then we can say that this array contains duplicates, right? Because after sorting, all the equal values 2 or 2 will be adjacent to each other, right? If this array contains duplicates, those duplicates will be adjacent to each other. Okay, that's the approach. That's the second approach. And the time complexity of this approach will be n log n. Sorry for my writing. Let me rewrite it. So the time complexity will be what? N log of n plus n. So this is for sorting, and this is for iterating over this array, right? What we are going to do here is, let's say our I is here. Our I is pointing at 0. We are going to compare this I with I plus 1. We are going to compare this 1 with 2. So both are not equal. So what we will do here, we will increment our I. Now again, compare I with I plus 1. So now we can see I and I plus 1 values are equal. So we are going to return what? True. Okay. So for sorting this array, the time complexity will be n log n. And for iterating over the whole array, the complexity will be n. So overall, the time complexity will be n log n. Okay. And again, the space complexity is constant. Why it is constant? Because we are not using any extra space here, right? We are just creating a variable. We are just creating a I variable. So that's not taking any space, right? I mean, it's taking a constant space. So yeah. So here the time complexity is n log n and the space complexity is constant. Now let's talk about the optimized, like the better optimized approach, right? The more optimized approach. Okay. So let me erase this first. This might take some time. Okay. The more optimized approach. For this approach, you need to know hash map, okay, or set. Okay, let's create a hash map first. So I'm going to create a hash map. Let's say here. Okay, this is the hash map I have, and I'm going to create a variable I, which is pointing at the 0th index. Now, what will I do? I will first check whether this value is present in my hash map. Okay, is this one present in my hash map? No, it is not. So I'm going to put this one in my hash map. Okay, 1 with occurrence 1. Okay, okay, now increment this I. So in hash map, we store it in a form of key value pairs, right? So this is key and this is value. Okay, so now I is pointing here. Is this 2 present in my hash map? Is this 2 present in my hash map? No, it is not. So let's put this 2 in my hash map. This is key and the value is 1. Okay. Now increment this I. Now my I is pointing at this index 2. Is this 3 present in my hash map? No, it is not. So let's push this key in my hash map 3 with the 1 occurrence. Okay. Again, increment this I. Now we will check for this 2. Is this 2 present in my hash map? Yes, it is. Yes, it is present, right? So if this 2 is already present in my hash map, it means 2 is occurring twice in this array, right? There is more than 1 occurrence of 2 in my array. So I can simply return 2 from here. So this is how this approach works, right? So as you can see, we are using this hash map. So the space complexity will not be constant anymore. It will be O of n. Why O of n? Because the number of elements I can push in this hash map, the maximum number of elements I can push in this hash map will be n, the size of the array, right? So this will be the space complexity, and the time complexity will be what? also O of n, because we are iterating over this array one time. Okay, and of course for every index we are checking whether it is present in my hash map or not, but the time complexity for checking that is just constant. Okay, so it is something like O of n plus O of 1. So overall it's what? O of n. Okay, yeah, so the time is O of n and the space is also O of n. So these are the three approaches in which you can solve this problem, in which you can tackle this problem. Okay, so now let's try to code it. Let's try to code the mesh approach. Okay, let's take a hash map first. Okay, it will be of type int comma int. Let's say map mp. Let's name it mp, and then I will iterate over the array nums dot size, and again first I will check whether map dot find nums of I is not equal to map dot end. This is how we check whether this value is present in a map or not. Okay, so if this is true, okay, if this is true, we are going to return true. Otherwise, what we will do, we will do map of nums of I plus plus. Let's say we will increment the occurrence. Okay, if after all, like after this iteration, if we have not returned true yet, it means there is no duplicate. There is no duplicates in our array. We will simply return false. Okay, so let's run this question. This is the first time I'm doing this question, by the way. So let's see whether my solution is correct or not. Okay, so it is accepted. It's submitted. Okay, it is submitted. Right. So yeah. So this is how you can solve this question. So that's it for this question. And I hope you liked the video. And thanks for watching and keep coding till the next video drops.